Hi there, everyone. I'm James Goel. I'm the MIPI Technical Steering Group Chair and MIPI Display Working Group Vice Chair. Today, we're going to be talking about the mass display stack. This diagram here talks about the kind of use cases that mass was designed to address. Here we have modern automotive cockpit displays, and there are lots of them. You can see here on the left side and on the right side mirror displays that have replaced the side glass mirrors. We have the driver instrument display, the center instrument display, co-driver display, and finally the lower control display. Not to mention, not shown in this diagram, we also have probably the rear screen displays as well, and the replacement for the rear mirror display. All of these displays have very high resolutions. You can see here the table on the right shows some of the example resolutions, and these are available in modern automobile cockpits. The other thing that is required is very low power and functional safety, and in some cases, security to make sure that these displays will work within electrified cars that are fully connected to a 5G network. So we found within MIPI that there isn't a series of specifications that pull together to create this end-to-end mass display solution. And that is what is going to be addressed with the mass display stack. This diagram here helps to understand the MIPI mass specifications dedicated to automotive displays. We call this our mass display stack diagram. On the left side of the diagram, you can see here how we've broken up the layers into four different categories. We have at the base, the bottom, the foundational layer is called the physical layer. Above that, we have the link layer, set of specifications. And then in order to get the MIPI protocols onto the physical and link layer, we use this protocol adaptation layer. And finally, we have the traditional MIPI protocol layers. So let's take a look at this example here when we have a MIPI display. Starting at the top, the traditional MIPI DCS and display services extensions are used to define how functional safety, security, HDCP are put onto the MIPI DSI2 display protocol. Then the adaptation layer also translates the DSI2 into an automotive format that can be viewed. The automotive format is then placed on the A-PHY link layer and then transferred to the physical layer. So you go down the stack when you're transmitting and up the stack when the display receives the information. The other thing about MIPI's mass is that it also supports VISA protocol. Here we don't tamper or touch the VISA DisplayPort protocol, but we use the MIPI DSE to allow it to properly translate into the A-PHY link layer format using the protocol adaptation layer. Let me explain how the mass display specifications can be combined to create a solution for mass automotive displays. This diagram will help us illustrate how that works. There are three parts to the diagram. The top, the middle, and the bottom are three distinct portions of the system. The top part of the system is the application processor or the electrical computing unit that generates the display information, the display pixels. The red lines indicate the A-PHY physical layer, which is the 15 meters SerDes, up to 15 meters can be transmitted on the red. And finally, the bottom part of the diagram has the display portion of it. Let's go back to the top here. In the ECU, it generates a display using two different potential protocols. Obviously, it can do the MIPI DSI2 protocol using compression, and it has the display source that supports security, functional safety, and then the ability to actually ensure that it's recovered correctly on the display. You use the adaptation layer specifications to convert the DSI2 over its C-Fi and D-Fi layer to the SerDes, which translates and transmits the video to the display, converts it back into its native MIPI DSI format or VISA format, as you can see here, for the display to render. The idea is that the display and legacy displays will work using this bridged APHI to APHI solution. And in the future, we believe that these APHIs will be fully integrated into both the ECU and the display. In combining all of these different parts of the system diagram, each specification can be used to implement your specific part, or if a vendor needs to, they would implement all parts of the specification throughout the chain. This is how mass can be used by a large variety of engineers to create an automotive display solution. Let's talk about where you can get more resources on the mass display stack. Here is a list of websites within MIPI where you can do deeper dives to get more information on the mass display. Specifically, I'd like to call out the webinar that I've recorded, Enabling Automotive Displays Using MIPI Automotive SerDes Solutions, or MAS. This and other more detailed information are available on these resources. Thanks for watching and listening. If you have any further questions, please email admin@mipi.org and they will happily get back to you.